Okay, this whole chapter is on solving systems of equations. Well, what is a system? Well, a system is when we have one, or rather two, or more formulas. We have two or more equations that we need to work with, and we need to find. So we like find like x, but now we're going to need to find x and y. Okay. So there are three methods that we're going to work on this chapter for solving these. The first method is by graphing. The second method is by substitution. And the third method is by elimination. And these little devils are going to be part of your algebra career from now on. Especially just graphing, like that doesn't go away. And really was worried about your graphing going into break. So I haven't looked at your test yet, but we'll see. So we'll review some graphing. You need to nail graphing lines, or this is going to be impossible. So graphing, what we're going to look for is we're going to look for where the lines intersect.
Wait, what's number 3?
Elimination. Okay? Now, I'm not going to talk about how we do 2 and 3 yet, because we're just going to be doing graphing today. We're looking for where they intersect. And so for the graphing method, we basically have 3 cases that could happen. Our first case is that they actually intersect. So I draw the lines, and something like this happens. And they meet. Okay? And when they meet, that's our answer, wherever they meet. Okay? That's our first case. So we're talking about just this method today, graphing. So I graph the lines and they meet somewhere. That's case number 1. And in case number 1, for the graphing method, we would say that that is a consistent system. Well, why is it consistent? Because I got an answer. Okay? And I would say that they're independent. Well, why is it an independent system? Well, because I have 2 different lines. So that's our first case. I graph the 2 lines and they meet somewhere. That gives me a consistent and independent system. Lost my tools there for a moment. Got to bring them back. All right, well, let's try one where we get the first case. And just to see what happens here. I'm going to graph. So what would this system look like? Here's what we have. Here's example 1. I'm going to have y minus 3x equals negative 6, and y equals negative x plus 2. And here's how I know that I'm doing a system of equations. How many do I have?
2.
I have 2 of them. So I'm going to graph both. Now, from our last chapter, we have two graphing forms, basically. Y equals mx plus b, our slope-intercept form, and y minus y1 equals mx minus x1. And we are going to review this second one today, but we're going to want this one. We're going to solve for y. So this first one, is that solved for y?
No.
No. Okay, so I'm going to have to solve that for y first. So that's our first step. I'm going to solve both equations for y. That way I can graph them. You with me? Mm-hmm. I have one person with me. The rest of you with me?
I have a question.
Yes.
On the top one, it says y negative 3x. What is the y equals?
Well, I have to solve it for y. So I'm going to take that y minus 3x equals negative 6. So I need to solve this for y. I need to get y alone. So how do I do that?
Add the 3x.
Add the 3x. Now, when I do that, I get y equals 3x minus 6. Now, that's not my answer. I'm going to graph this. Okay, what about this second equation?
Is solved.
It's already done, so I'm going to graph that one too. I'm going to graph both of them. And where they meet is the answer. If they meet, okay, that's the answer. If they don't meet, then we have one of the other cases. Now these are going to meet somewhere. So I'm going to graph these two lines to get my answer. So let's do that.
Wait, what happens if they don't meet?
That's the case that we're going to talk about next.
Okay.
Okay, so we're graphing. First of all, we're going to graph y equals 3x minus 6. How do I do that?
You'll find the negative 6 on the y thing.
Yep, on the y-axis I go down to 6. 1, 2, 3, 4, 5, 6. On the y-axis, because it's a y-intercept. And now from there, what do I do, Austin? Go ahead, Austin.
You go up 3 and right 1.
Yep. And I'm going to do that a bunch of times. This is going to be very important. Remember last chapter I told you no short stubby lines. Very important for this chapter that you don't have short stubby lines because I need to look where they meet. And I have no earthly idea where they're going to meet. They will meet somewhere unless they're parallel, which we'll do that next. All right, what about the other one?
You'll find the other 2.
On the y-axis up to 2. Now what's my slope, Dylan?
Slope is nothing.
No, it's not nothing. What is it, Ryan?
Down 1, right 1.
Yeah, it's a negative 1. So that means down 1, right 1. So from here I'm going to go down 1, right 1 a bunch of times. And again, I draw that through, use a ruler or something. And they meet somewhere, right?
Mm-hmm.
They meet right here. Answer. Well, what is that answer?
2.
Well, it's not just, it's 2, comma, 0. That's my answer. See, this is x, and this is y. So remember, for solving a system, I'm finding x and y. So when I go back to my problem right here, what's my answer? It's not this stuff. My answer is 2, comma, 0. That's where they meet. That's the final answer. X is 2, y is 0. Because remember, we are finding x and y. So here's what this means. If I put 2 in for x and 0 in for y, these should work. Let's try it. You don't need to write this down, but let's try it. If x is 2, so I'll go to this one. Y is what?
0.
So 0 minus 3 times 2 equals negative 6. Negative 3 times 2 is negative 6. And does negative 6 equal negative 6?
Yes.
Yes. So it worked. But it has to work in both of them. So if I go to the second one, y is 0 equals negative 2 plus 2. Negative 2 plus 2 is 0. That one worked. It has to work in both of them. And it does. So that was my answer. Let's try one more where we actually get an answer.
I'm guessing that was a substitution rule. Was that a substitution rule? No?
No. Nope. But I did substitute in. That's correct. I did substitute in. But that is not the substitution method. Let's do y equals x plus 5 and y equals negative 4x. We'll do 2 more of these that we actually get one for. 2y plus x equals 2. So this is the first system. Second system. All right, so we're going to do both of these together. Now we will get answers for both of them. They will meet somewhere. So this one, I'm very happy about. Why am I happy about example 2?
Because it's already solved.
It's already solved for y. And I'll take it that you guys have already written that down, right? So we go to our graph. And I'll have to delete these lines. So just give me a moment to delete those. What was the first equation?
Y equals x plus 5.
Okay. And someone else, what was the other one? Negative 4x?
Yeah.
Okay, so someone else besides Taylor, how do I graph that?
You go up 5 on the y-intercept. Y is on x is 4.
Okay? And then from there, what do?
Up 1, right 1.
Okay? Now, someone else, how do I graph the second one?
You start at 0.
Start at 0, because my y-intercept is 0. And from there, what do?
Down 4.
Down 4,
Right.
right 1. Okay? And notice, they meet somewhere, don't they?
Yes.
Now you're going to want to use a ruler for this, otherwise your lines will be all crookedy, and then you won't get the right answer. Okay, so what's our answer?
Negative 1 4.
Negative 1 4. Now, if I wanted to test to make sure that's right, I would replace x with negative 1 and y with 4. And it would have to work in both of them. So if I tested this first one, y is 4, x is negative 1, and 4 equals 4. That worked. Do you see what I mean? And then I could test the second one as well. 4 equals negative 4 times negative 1. That's negative 1. 4 equals 4. Yes, it has to work in both of them. All right, let's do the other one. So what was our answer for that one?
Negative 1 4.
All right, let's do this one. Now I'm not so happy about this one. I have to do what first, Meredith?
You have to solve for y.
All right, so you solve the first equation for y. Have 2y plus x equals 2.
You minus the x.
I minus the x, so minus x. So I get 2y equals negative x what?
Plus 2.
Plus 2. Now what?
And then you divide 2 by everything.
Okay, so I get y equals, now this 2 applies to everything, so I get negative 1 half x. Any questions where I get that? And then what's the last part, Meredith?
Plus 1.
Plus 1. So that's my first equation. Someone else, we need to do something with this second equation.
Subtract 3x.
Subtract 3x. And I'm done on that one. So I'll give you a moment to write that down. Now, as you're writing that down, listen, it is going to be essential. You know, you've had to show work before, but I am telling you, the amount of work to do these correctly is going to be a lot. All right, so you'll notice that your assignments are shorter. Well, they aren't really shorter. You have less numbers to do, but they will take up more time each. Okay, so you need to be, very important to be organized in your work for this. You see how I'm organizing it? I'm just showing. You'll have lots of arrows and things, so you're showing where your work is going. So I'm going to graph both of these, and what I like to do is I like to half box half answers. To me, these are half answers. Like they're an important step to get the answer, you see what I mean? And then I full box my final answer. That's just a Mr. Kane thing, you don't have to do that. So somewhere I'm going to put a full box, like what is that final answer I'm going to put in there, whatever it is. So right here, here was my full answer. I didn't have any half steps for that one, I just graphed that. So I need to graph these. So I hope you have those written down. So the first equation was what? Y equals negative a half x what?
Plus 1.
So someone who hasn't talked to me yet, how do I graph that?
Up 1 on the y-axis.
Yep,
And then down 1, right 2.
yep. So I get something like this. Notice I'm putting a lot of dots because I don't know where these are going to meet. Okay? And someone else, the other equation was negative 3x what?
Minus 3.
Okay, so someone else who hasn't talked to me yet, how do I graph that one? Go ahead, Trey.
You go down 3,
Mm-hmm.
and then down 3, and then right 1, and then you're gonna go to the back to the down 3. You know what I'm talking? Yeah, do that.
Yes. Okay, he is correct. Okay, I connect those. Now, notice something that didn't happen with our other two examples. This meets right here. That's kind of a weird spot. Well, what is that? I have to guess, right? And what's my best guess? Well, it seems to be between, this is -1 and -2, so I'm going to guess -1.5. Does that make sense why I guessed that? And I'm going to guess, well, gosh, this is really close to 2. So it's 2, I don't know. It's not 2.5, it's more than that. 2.75 maybe. Does that make sense? No, it's not 2.75, 1.75. You see what I'm saying there?
Yeah.
Okay? So that brings us to a weakness of our graphing method. So right here, where we talked about the graphing method, it's good to see what happens. That's what's good. We see what happens. But often, we have to estimate. That's a weakness. Okay? That's a weakness of the method. The strength is that we get to see what happens, but a weakness is often we have to estimate. And that was the case in this one. So we don't know if that's actually the right answer or not. In fact, I bet if I plug it in, it actually will not check. It'll get close, but it won't be exactly right. Okay, so now we're going to do the next type. Okay? So the next type, we have our one where they meet. Our next type is something like this. And what seems to be true about these lines?
Parallel.
They're parallel. Okay, this is the parallel case. And parallel lines have the same slope, right?
Yeah.
So you don't even have to graph these. As soon as you recognize that they have the same slope, you're done because you know that they never meet. So we call this an inconsistent system. Why? Because there's no answers. It's still independent. Why is it independent? Well, I have two different lines. And I'm going to go ahead and talk about the third case because it's very similar. I graph one of the lines, and then I graph the other line, and it's right on top of it. They're on top of each other. So they're basically the same line. So that's our third case for graphing. I could have them meet, I could have them parallel, and they could be the same side. So this is actually a consistent system, but there's infinite answers. Why is it infinite? Because the lines are right on top of each other. But it's not independent anymore. Why? Because it's the same line. It's dependent. It's actually one line. I might have two different equations, but I only have one line. They just are on top of each other. So when you have a line on top of itself, what are we going to write for our answer? We're going to write infinite solutions. Well, what if it's parallel? It's like what Sarah was saying. What if they never meet? Well, then there's no solution. There's no answers. So I really don't want to go through graphing on these, but I do want to go through, well, what do you do when this happens? So we might have something like, I see that you're still writing, so we might have, I'll let you finish writing. Do I see you still writing? Okay. So what's an example of this? This will be example 4. Maybe I have y minus 2x equals 5, and I have y equals 2x minus 3. And this is what I'm supposed to solve. So the first equation, what do? I just start like I normally would. I have to solve for y, so what do I have to do?
Add the 2x.
Add the 2x. So I add the 2x to both sides, and I get y equals 2x plus 5. All right, that's halfway mark. And this one, do I have to do anything to that one?
No.
But what do I notice right away?
Slope should be.
Look at this slope.
Oh,
They're the same.
They're the same. Okay? They have the same slope. So I could graph this And when I graph it, I would notice that they're both going up, like that, but they never meet. So what am I going to write? No solution. Because those slopes are the same. So our last example is going to be where they are on top of each other. They're the same line. You good? Example 5. So, y equals 3/2 x minus 1. And maybe here I have 2y minus 3x equals -2. All right, so I go through my steps. This one's fine, right? That first one, I don't have to do anything. So I would get ready to graph that. But I'm not going to yet because I want to check the second one. So the second one, I'm only going to start graphing if I see that they're actually possibly going to meet somewhere. What do I need to do to this one?
Add the 3x.
Add the 3x. And now what do I do?
Divide the 2.
So I get y equals 3/2 x minus 1. Now this time, I notice that, are the slopes the same?
Yes.
Yes, but what else do I notice?
They're the same.
They're exactly the same. So it's actually one line. So what am I going to write for my answer? Infinite solutions, right? Infinite solutions. Okay. We are going to do one more thing, and then you will have a bunch that you need to work on. So, we are going to do this question. Is the point a solution to the system? That's the question we're going to have. So in this case, I don't have to actually solve it. I need to find out, well, is the point I'm given actually an answer? So here's my system. Y equals x plus 1. Y equals 2x minus 1. And my point is -2, 3. This is my point. And I'm asking, is this a solution? Does it work? Well, what do you think you should do? Could I graph these two and see if this is actually it?
No. Yeah, you could.
I could. That's the long way, though.
Yeah, just to substitute.
Yeah, put it in.
Oh, that's
Do you see what he's saying? Now, here's the question. Which one do I put it in?
Both.
Both. It needs to work on both. I need to test both. So here's a common thing that'll happen. It'll work on the first one, but not the second one. They're trying to get you to be lazy.
Wait, where'd you get to -2 probably?
I'm giving it. Is the given point a solution to the system? So what do I put in for y?
3.
And I have -2 for x, and 3 equals,
No,
It's 1. Wait.
it's -1. But that's not true.
so did that work?
No. Why?
No. Okay, so it didn't work. Do you see what I'm saying? So is this a solution? No, as soon as it doesn't work, it doesn't work. All right, let's try another one. Maybe I have, let's see here. X minus y equals 1, and x equals 1/2 y plus 2. That's my system. Now, normally I would solve for y here and graph it and all this weird stuff. But if I'm testing it, then I don't need to do all that. So I'm going to test this point. So I put it into the first equation. So I get 3 minus 2 equals 1. What's 3 minus 2?
1.
1 equals 1? That's true. So it worked in the first one. But I need to test the second one just to make sure. So I put it in the second one. So I write 2 equals a half. Wait,
Why is it
3, right? Because this is x. I need to keep my x's and y's, right? So what's a half of 2?
1.
So 3 equals 1 plus 2. 3 equals 3. Does that work?
Yes.
Yes. So is that a solution?
Yeah.
Yes. Now often what will happen is it'll work in the first one but not the second one, which is why you need to test both. Test both of them. Okay?
Wait, what happens if it works? Never mind, I did it.
Okay? It has to work. If it doesn't work in one of them, it's not a solution. So why is that the case? Here's what could happen. You don't need to write this down, but I want to show you what's happening. So here's one of the ones that we did. So look at this line. So here's one of the lines. Look at this point. Okay, that point works in that equation, right? This point would go into that equation, works fine. But is it on this other line?
No.
No. So this point does not work on that line. See, when we're doing a solution, it's what works for both lines. We're basically saying what point is on both lines. Now, we could have more lines. We could have 3. We could have all sorts of crazy stuff that we'll work out later. All right, you can put your notes away, but I want